This is going to be the first of many recordings that I'll be providing for you that are going to be what we'll call screencasts. And essentially I'm able to take a video and record my voice, my audio, over the whatever's on the screen itself. And I'm going to talk you through how to go about reading textbook. And I think it's important that you get better as a reader to understand the depth and the breadth and the scope and the scale of what college text material is trying to provide you, the learner. So here we're going to talk through chapter 1. I'm going to show you some highlights, how to go about how I would recommend you navigate reading college textbook and college text material and be able to make it a productive experience. So here goes. I'm just going to scroll through here. This is an online textbook. I showed you how to get to it. And notice the layout of the text itself. We've got these headings here. What is earth science? Obviously that the reading aspects, the more you practice it, the more you do it, the better you will be at it. Clearly bold-faced terms are going to be kind of content-based terminology. It's the language that's going to be used. Here we have geology, meteorology, astronomy. These are 3 of the 4 domains of earth science. We also have oceanography, that's the 4th. So earth science, this class, is going to be about all of the sciences, including geology, the physical earth, oceanography, right? We can't ignore that the blue planet is driven by these oceans, this salt water. Meteorology, the interaction of the atmosphere and the processes that produce weather and climate. And astronomy, kind of Earth's location in space and its evolution as to how it formed. So notice the layout of the pages. This one here would be more of just kind of a background piece of information. Here we start applying earth science, people, and the environment. Moving on here, we can look at, blue is just like a subheading of the red. The red are the big headings, the blue fit within the subheadings. So this would be a subheading, this would be a heading itself. I always think it's a good idea to look at the pictures to read what the figure says. The pictures are going to help give you a display of what's taking place within the text itself. I'll be reading this to you here in a few minutes. I'll be kind of going through this with you. I just feel like it's a really cool story to understand how, when, and why we came into being as not only Earth but life itself. Once again, some more pictures. Here's the timeline of a 14 billion year existence of how the how the cosmos formed, and then how Earth kind of found its way into, let's just say, into existence, where and when that occurred. We'll be talking here some more terms, bold-faced, population growth. We're going to be looking at sustainability of the planet. Energy is going to be a common theme. Here's just a picture of wind turbines generating electricity, and these are commonplace in Illinois now, so you've probably seen them alongside the road. Environmental problems, we'll be talking about how Earth provides us materials and humans find a way to cope and use them, and we create secondary problems. Moving on here, the nature of scientific inquiry, essentially the ability to ask questions and to go about solving them, very important. We are going to keep moving on here. Hypothesis, theory, different parts of how science kind of goes about its business. Here we have a scientist taking a look here at a dinosaur bone. And let's see, keep moving on. Scientific methods, simply a process of doing science. And notice I'm just giving you a layout here. I don't want to make it seem like I'm overlooking the words in here. The words in here are painting you a picture. And so when I discuss these topics, or when we discuss them in class, it's very important that you have the basis or the background of it. Studying the Earth from space, a topic we'll be studying at depth is how we use remote sensing technologies, that we don't have to be everywhere on the planet to actually observe it. We have technology, and satellites provide us this. So remote sensing technologies allow us to pretty much be everywhere and anywhere on the Earth without having to be there physically. Scales in space and time in earth science. Space and time are 2 common themes. Where did it occur and when did it occur? We can keep looking at, here's a picture. I think it's a really cool picture to think about. We're going to be studying the microscale and the megascale. Here I have a picture of an atom. Atom is a building block of a mineral. Minerals put together and assemblage form rocks. Rocks are what compose the exterior Earth's solid structure. Here's a picture of a mountain. Right? The Earth's external structure is what builds Earth itself. Earth is located as the third rock from the sun, right? Mercury, Venus, Earth. Earth is the third orbiting body around what we call our sun. It's the star in our local neighborhood. And then notice our solar system is located on the outer fringe of our spiral galaxy. So this is the Milky Way galaxy, and we are located kind of on the outer fringe. Here's a geologic time scale. We will be studying geologic time in depth, so we can take a look back here at the Precambrian, which represents about 88% of all geologic time. In other words, most of the Earth's time was just kind of forming and kind of building itself, and life formed, or excuse me, the first fossils have been found about 3.6 to 3.8 billion years ago. So way back here, the microbes began forming. So it took them about 2 billion years to get to the Cambrian here to really master cellular processes. And this is where we start seeing multicellular life. Moving on, let's see, early evolution of the Earth, just another geologic timescale issue, right? We'll talk about how and why it formed. It all comes back to scientific testing. Nebular hypothesis is a strongly supported hypothesis, because we can view out into the cosmos and see planetary systems much like our own solar system forming today. So we can say, well, if we know they're happening out there, we can say it's pretty safe to say that that occurred with Earth's history. Here's a really cool illustration here, and I'll kind of read over here while I talk you through the picture. The birth of our solar system, which began as dust and gases, started to gravitationally collapse. B shows the nebula contracted into a rotating disk that was heated by conversion of gravitational energy into thermal energy. C, we have the cooling of the nebular cloud caused rocky metallic material to condense into particles. Repeated collisions here at letter D caused the dust-sized particles to gradually coalesce into asteroid-sized bodies. And then E, within a few million years, these bodies accreted or built together into the planets. So we have this evolutionary set of features that took place that further support nebular hypothesis. Then we move into the Earth's spheres. We have the hydrosphere, right? Hydro, water, the water-based, the liquid that is constantly in motion. And here's a picture from the moon looking at the Earth. And obviously here's a picture of the Earth itself. We've got our atmosphere, right? The gases that envelop the Earth itself form our atmosphere. We'll be studying meteorology all of third quarter, and we'll be getting to climate systems even first quarter. Our biosphere, right? Where do we find life, and what are the interactions that take place with life? Let's see here, another picture here. There's a jet, right? Obviously technology allows us to be mobile. We'll be looking at let's just say organisms in the oceans that'll help provide a timeline as to the evolution of life on the surface. So when we start looking at the geosphere, right, the rocky structure that builds the Earth, we're going to be studying and focusing our time on the Earth's internal structure, right? What's it made of? And I can show you this picture and kind of give you a preview of that. But the Earth has a structure to it. It has an inner core, a solid inner core, dominated by iron, some nickel. It has a liquid outer core, also iron and nickel. It has a large section of mantle. The Earth is mostly mantled. And then it has a thin outer rocky crust. It has both oceanic crust and continental crust. And we'll be studying this at depth. Let's see, moving on here, we'll be talking using terms like Pangea. Pangea was the most recent supercontinent, about 200 million years ago, 2 to 240 million years ago. All the continents were connected in some way, shape, or form. And they have since moved. And we'll be talking about what we call the mobile geosphere, right? The geosphere, the rocky surface structure. These have moved. And we call this process plate tectonics. That since Pangea, we've broken up. That North America headed this way, and South America headed this way, and Africa headed this way, and Eurasia headed this way. And what we see 200-ish million years ago is not what we see today. And there's a reason for that. And there's a very good scientific explanation for that. So this is what we would call a cross-section of the Earth. If we looked at, so here I have South America, and I have all these different terms that go with this cross-section. I have divergent boundaries where oceanic crust is moving away from oceanic crust. We have convergent boundaries. I have oceanic crust subducting. Subducting is the process of moving under continental crust. So oceanic crust is going to be denser, and it's going to sink as it comes into contact with continental crust. And this is just a loaded picture here. And once again, we have units that'll break these down. We'll be talking about processes of heat transfer. This is convection. We'll be studying convection in several different ways, and we'll actually be doing this lab here. And major features of the continents. We'll be studying mountain belts. We'll be talking about features of the ocean basins. We'll be talking about continental margins. That's the edges, what's happening, right? The United States, the west coast, is very geologically active, where the east coast is what's called a passive margin. Not a whole lot of volcanism, not a whole lot of earthquake activity. So the east coast differs significantly to the west coast, even on the United States. Here's a map of the Pacific Ocean, right, the largest ocean on Earth. Here's just a picture of where we see these convergent boundaries, where oceanic crust is subducting beneath another crust, and we've got these volcanic rings. And this area right here that we can highlight is the Pacific Ring of Fire. Very volcanically active. Here's the Marianas Trench, the deepest part of the Earth. So we've got a lot of different features, a lot of different terms, and that's why reading the textbook is so important. Here's just another map that we can look at, oceanic map itself. And as I move through here, I want to continue to remind you that the Earth as a system is a common theme. And we're going to start using the terminology, the Earth system science. And we read about a topic called Gaia. And Gaian science is actually the idea that the Earth is a multifaceted set of systems that all interact with each other simultaneously. And last but not least, we can look at the rock cycle simultaneously to the hydrologic cycle or the water cycle. That here we have surface processes, here we have internal processes, and yet they're interrelated. And they literally feed into one another. We'll be calling these feedback mechanisms. So we've got a lot of terminology that we're going to jump into, and it is your job as the student to begin making sense of them. And to read about it gives you ammunition to be able to come to class and talk intelligently and have opinions and have interplay with dialogue with your peers and your colleagues as we delve into this college level class. And aesthetics. Let's not ignore that this is a pretty cool picture. This is the recovery site from a massive volcano that erupted here, Mount St. Helens. And what's ironic that life finds a way to persevere. And at the end, chapter summary. These are really good bullet points. Make sure you take a look at the end of the chapter, and these are good highlighted points. After you've read it, these kind of condense it down. I don't think it serves you justice to just read these. There's so much you miss out on. Here's a couple more bullet points. Here's a list of the terms, and a lot of the review questions at the back we'll be hitting and completing these and doing these, and these will lead our discussions, our group work, and they'll be the review questions that help drive us and push us forward. And you have a reference on the textbook. So there you have it. There's a preview. Most of the textbook pieces that I'll be sharing with you will not be this long, but this will get us started. Best of luck.